All right. I should have audio. Okay, audio. All right. It's up really close, and it's made out of iron infused PLA, so the whole thing is like a magnet. Piece of iron. Low permeability, but it's about 45% iron, so that's how much of a pull you get. It's really weak, but it's enough to have to like fix the coil or back it out. But it's maglev now, so it's floating there. Nine and a half. Oh, that's sweet. All right. This is the one that's hooked up to everything, though. Wow, that is so smooth. I can barely hear that. It is about picking up EMF contactlessly, like, you know, you do it. And we're going to check out the size of our field here. And it's all in preparation for making a, I don't know, a hexagonal propagator. And if you allow me to explain the steps we've taken to ensure that it functions at least the way it's supposed to, we've got our main drive coils, which are 1,500 turns of 20 gauge, single file. We got a signal generator. And those are our main things. Now they come in sections. Oh, there's one more main thing, and that's what we're working on today. That's what we use to pick up the EMF. Now, what I'm planning on doing is having several smaller coils aligned on the pole of the magnet here. So lined up on the side on the edge, like right here, I have like 6 coils lined up. Each one of those coils gonna have 1,500 turns of 32 or 38 gauge. So it has a total of 9,000 turns of 32 or 38 gauge. Now, what that's going to allow for us to do See, right now I got 9 volts going in and 600 milliamps going into this one right here. What we need to do then is have the pickup coils equal at least 2 volts more than what I'm putting in. Can equal more than that, but we're going to try and balance it out. Our input's going to be 12 volts. So 12 volts will go into this first coil here. We pulse it with the signal generator so the transistor will fire. Got to find the right frequency though. We're going to have to play around with it a little bit. Then I'm going to call it, we fire it off. So, we hit the button and the frequency goes through and it pulses through, and then our pickup coils, which will be on the end here, and that'll equal a side, like right here. This coil and its pickup coil is one side of this hexagon, so it's going to be like this big. And so we're going to go from one to and I don't know exactly how it's going to work. What I'm thinking is going to happen is when I get it done, get it all set up, I'm going to pulse it. Each section is going to have an LED too. So, I mean, like if the section's hot, the light's going to be on. I just have a feeling like all the lights are going to be on at the same time. And we can do that, but then we want to do something else with it too. We want to have them go in sync. We want to have them go in sequence, do weird, crazy things. And we should be able to, with the circuitry, decide like if it's going to go doo, 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 or if it's going to go have them all be on at the same time, which would be really easy to do. But LEDs aside, I think that this, if we make it so the energy being picked up from the coil, and I'm going to show you right now, it's already way over what we need. But this is an 18,000 turn coil. And with the standard LED, I mean, you have a load because the LED is definitely not, it's not load free. You can see it, maybe you can't see it. I'll have to point it, or I'll just grab it. See, that LED is on now. I will start up the multimeter and turn it around for you guys. I don't see how you could use anything here practically. I mean, it's already been done 600 times. So it's not about that anymore. You know what I'm saying? Just like working in the future when the robots are doing all the mundane work and you're looking for a job, you're looking for a job not because you have to work, but because you want to. Because there aren't going to be any typical jobs available for anybody. They're already all going to be done. So like, what you do for a living isn't going to be about money anymore. That's just my hypothesis, my opinion. With the way robotics are going, it isn't going to be long. So it's for fun. I mean, it's practicality isn't an issue. In my mind, it's not very practical. It's very expensive. It's fun. That's why I'm doing it, just to watch it happen. And what it's supposed to do, especially if it's unfiltered, without any capacitors in it is propagate. That's what it's supposed to do. It's supposed to increase in voltage each time that goes around the cycle. Or maybe you need caps. I'm not exactly sure about the caps. I have caps. If I need caps, I can put caps in each section. And then the section should be, you know, modular. And you could take this section, copy it, and put it right in front, and it would, and you got two sections that you can put together. So, I mean, like, if there was a practical use for it, it would be very, once I get it all done, very linear, man. You could throw it on a freaking assembly line, no problem. What does it do? I don't know, man. It's like a train. It's like a train that you put under the tree, man. That's what it's like. This stuff, anyway. This is all for, it's a light show. And I mean, there could be several measurements that we could take, especially when I get all 6 sections, you know, into it. I'm just debating right now on the size of the bobbin, the size of the former for the 6 coils that are going to go around here. Each one of these little coils that I make has to generate at least 3 volts. 3.1 volts times 6 will give us 18 volts. Now, if we want to like shove it all into a capacitor, a 12-volt capacitor, because we want to use 12-volt bursts to set off the coil. So we want a 12-volt capacitor that's going to dump all at the same time, not let out gradually, but just go like that. That's what we need. And then that way, even if it's going like, I don't know, I mean, I think I know what I want, but I'm not sure. I mean, I've never been here before with this stuff. I'm usually just doing something with the wheel, and we're measuring, you know, the light. This light over here, this big one right here, I got this one down to a T. You need, when the switch is on, it's got its own power switch. So when the switch is on, you need 65 volts of whatever energy you're gathering to make it start to turn on. So it's a really powerful light too. I mean, all right. So, but this is maglev now, and I think that's pretty cool. I'm going to see if it's helping or hindering being up in the air like that. Ooh. Here, let's see. It might not be good. All right. So here, we'll turn this on. I'm going to turn it around so you can see. Huh. Well, anyway, this coil would be good. I mean, it's big coil. It's 18,000. So when you got your light lit, and then you got like 3.5 volts on top of that, and that's exactly what you need for each one of those little coils. But that's an 18,000 turn coil. It's not a little coil. All right, so all right, it's more like 4.6 when it's right up to it. That's way more than enough, but I need to put 6 of these. So that's like 38 gauge or 40 gauge, 42 gauge. And then I can cut it way back. Oh, where's that thing? Here it is. $2,100. So it's worse. I think it's because there's way more vibration in the shaft. The higher it is, the more vibration there is. Because my shafts are fixed. I like using the bearing. It's weird how I make it sound like you're not using the bearing if you spin the shafts, because you are. You're just using it like that. I don't know the word for it. Because if you spin the shaft, then you got to put the shaft through a bearing, and the bearing is being held still on the inside. It spins on the outside, or I don't know, because that's not exactly the way it goes, but I would think that bearing would be attached somehow to the base of your contraption, allowing the shaft to spin freely, on the top and the bottom. If your shaft is spinning, you want it supported from the top and bottom. Like this one, if it got any higher, I'd have to give it top support. All right. All right. Gotta get a rag here. Wipe that off. All right. I think I'm gonna back it off just a little bit. There we go. Now the center of gravity is a lot lower. And I believe it can spin a lot faster because there will be less vibrational friction. Completely different experiment. That's how I feel it's going to end up here. Oh, and another thing I wanted to do is hook up this fat light again. It appears that I'm getting like much lower readings. So do 100 volts right now with contactless EMF pickup. Lost 30 volts just backing it out like that. So it's got to be like right on top of the coil here. It's got to be like right on top of it. All right, this is 9.2 volts in, 600 milliamps. Let's see what we're working with the speed. This Litz coil right here, the one that I'm using for the drive right now, is very responsive to voltage. So the voltage out is very responsive to how much you put in, how little you put in. $12 volts. 2,000. 2,100. Now we're making 170 volts with the 18,000 turn coil. Nice. All right, we are within 5 volts of being able to turn that light on. $22.65. Oh, it's not going to happen. I got to cut this back. It's got to be a little bit closer. It's got to be a little bit closer, but I've turned it on. I've turned it on a few times. Here we go. You can't really tell because it's so bright. Let me hit the light. Yeah. All right, so that's enough. That's a 100-watt LED that replaced. It's, instead of 1,000 watts, it's 100 watts, and it takes 65 volts. And let's check the amps. I haven't checked the amps yet. 1,500 are 1 amp and 500 milliamps. 1.5 amps. That's what I'm looking for. Yeah, I'm generating 1.5 amps with the light on. Yeah. Woo. That's pretty good, man. And for a 32 gauge coil, I don't care how big it is, man. That's pretty good. You turn it off, and I'm like making 4.5 amps without a load. $2,324 RPMs. Wow, that's awesome. So I think with it being level with the table, it's got a little bit more room to spin. Honestly, it's because I don't have any top stabilization, and you get a lot of vibrational friction in the shaft. And I feel like everything I would try to brace the shaft with would not work. Even if it just wouldn't work. I need to I can't use this table and make it legitimately good, because the vibration when it gets going, no, dude, it's just going to tear apart everything that you try and brace it with. So unless you start with a different base, and then if it's equal, you do it smarter. And it wasn't that I didn't think about it, it's just that I didn't know the name of a lot of the stuff I was looking for. And I don't have tools to work with like acrylic and stuff like that. I would buy the acrylic discs already pre-made with the center hole already cut out. That's how I would do it. I mean, wow, yeah, but acrylic base, that would be good. I have another base behind me that I'm working on. It's made out of wood, but it's a lot tighter area than that, and I have to drill all my own holes into it. So it's a give and take. Got this AC variable voltage. All right, and then this whole board is good. If I put more shafts in it, they're 10 millimeter shafts. So this table and that table are not compatible. You can't interchange them because the shaft size is different. I was trying because I've had a lot of catastrophic failures with the 1/4 inch shaft. I bent a freaking 1/4 inch shaft in half with one of my rotors when a magnet got thrown out. And literally, this is how it got thrown out. You see this edge right here, the side broke right off and it just flew out. So the magnet went that way and the rotor went that way, and the shaft went with the rotor. I was holding on to the shaft at the time. I was just holding it like this, and it went boom, axial flux style. So like the coils were underneath. It was terrible. I still haven't found the magnet yet. Oh man, I haven't looked very hard though. Mm-hmm. What's up, Tiggs? Meow. Yeah, he's a great kid. Cat. Kit Kat. Oh man, I love it that I can turn this light on. That means any LED that I have will turn on with this coil. But what I'm thinking is like a 1/2 inch center hole with like 1/8 of an inch, not even that, like a 32nd of an inch, well, just enough around the center hole to make it so I can put a core in it. And I can wrap the wire around it. And then it has to all fit inside an inch of space. Those are your dimensions. You can have an inch and a half in length, because these are 3-inch bobbins. So you can have an inch and a half in length of the bobbin, and then it has to fit within an inch. I mean, if you're going to do 6, I don't even know if you can do 6 with the center hole. But it's good to have that hole there. There's a hole in all of these. And I shoved a piece of iron in this one already, and it helps a lot. Even with the pulsers, the drive part of the whole thing, it helps. And this one has a core in it. This thing is heavy, man. This thing is like 2.5 pounds, 18,000 turns. Oh man, it's only like 1.5 pounds. Think. No, it's closer to 3 pounds. I mean, I've had it now for like a year, so. And it's simple. It's just the simplest thing, and it was great to make it because I still have it. And when I saw that I was generating, almost 5 amps without a load, of course, I was like, wow, that's freaking crazy. That's awesome. I mean, I don't see that every day. Oh man. And then with a load, it's a heavy load too. It's not just a light, an LED, 12 volt. Let's just call it a 65 volt LED. Which is still easier to light, I would imagine, than a 90 volt neon bulb or a 120 volt halogen light bulb, which these circuits light up all the time. So, I mean, I don't know where the power is. I know that like through induction, this coil will not be able to light the halogen bulb. This bulb right here, it won't light this. And it doesn't matter how long I let it run for or whatever. I don't know what the deal is. I'll probably keep trying to do it. Hey, what's up? Hey, Brian. All right. So I was thinking about, well, I think like a pulse width modulator, I think is what it is. PWM might be a better idea than the whole signal generator setup for this. It virtually does practically the same thing, or the same thing that I use it for, what I should say. So I'm thinking definitely we're going to go with 4. No, we're going to go with 6. We got to go with 6 because at 1,500 turns a piece, maybe 1,600 turns. I think we'll get enough power because that'll be 9,000 turns. $2,100. Yep, 1.5. 2,100, 1.5 amps, which is 5.5 amps, 500 milliamps over what it's taking. And I have it opened all the way to 20. Oh, that's making me excited. And that's with the load on it, man. This coil is amazing. Hold on a second. I saw somebody walking by. I think it's a meter checker. I want to see what type of wave is coming off of this when it's on. Oh, that's right. It doesn't show up when the light is on. Oh, wow. That's a rich spike right there, man. 600 volts. 600 volt spikes off of this. And in between 5 and 600. That is so neat. All right. So I'm going to try and turn this around without disturbing anything. Then I turn the light switch on. Light goes on. So dim though, it's like just on. It's like not really on. You know what I mean? And that light is enough to eat up all of that energy. All right, so I've figured out that if we look at how much space we have, we should be able to, if we make all the pickup coils with the hole in it and size enough for an iron core like this one, could we fit 6 of them on the face of this right here? I don't know. I think we can, but all the other dimensions have to be like pretty exact for there to be enough room. I know we can make the holes. We can make it so the holes will fit and encase them, but you got to put this face on it so you can wrap it properly. And then put 1,500 turns on each one of them. So that'll be a total of 9,000 turns, which will be half of this. And I think that'll be way more than enough altogether for this thing to work well. So, I mean, just to fill in the blanks of what we don't have, let's look at what we do have. This is 18,000 turns. Where's that one that I was just playing with? This is what made it all possible. This is 3,000 turns. That's how I figured out all the rest of the math. That's 3,000 turns of 32. And this one generates about 10 to 11. And we need it to generate 3. So it needs to be about half of this amount. And it needs to be able to fit 6 of them on the face of this magnet. I know I just said that 100 times in different ways, but that's where I'm at with what I'm doing. And I think it's going to end up being 1.5 inches long, so about that long. And then it's going to end up being like a 4/5 of this edge are going to disappear. So there's just going to be a very small edge, small face. When you put them all together, it's going to be really awesome. And then because we have them in multiple coils, if we ever wanted to change how it's hooked up, like do a parallel setting instead of a series, or try different things, do 3 series in parallel, you could do that. Just hook 2 of them together 3 times, send those onward. What, we're going to figure out what's going to work best. And because we have 6 coils with ends on them, we can hook them up any way we want. All right. What's up, Mike? How's it going, man? Awesome. Awesome. Thumbs up. I want to get my head in here a little bit. My chessboard down there. Me and my cat like to play chess. Well, he's playing fetch. All right. I love it, man. Just has to be going fast enough. So each spike on this, once it gets going fast, is in cycles. So each spike is actually 4 spikes. Or each blip on the radar here is actually 4 blips. Just going so fast. You can really see it when you first start it. Wow, that's amazing. That's 2100. We'll look at it in a minute. All right, so and it's weird because these are all 1500 turns. The big ones are 1500 turns as well. And I'm going to make all the little ones now 1500 turns. And it's the way it's supposed to be. And I didn't do that on purpose. It just happened. I love it when things just happen and they make sense and they're in sequence, or they may even rhyme or be in a pattern. And it was just meant to be that way. And it didn't really take any effort. That's okay. That's good. A lot of people like to put in effort when they don't need to. I like to, I don't even know. And I don't know if, what I said is even right. I bumped into a few people and I don't know many people. So it's accurate for me. And a lot of things that are accurate for me, like, yeah, it's, haha. And I'm not acting like my poop doesn't stink. I'm acting like my poop might stink more than most. It's more like that, you know? Was that 12 point now? Now it's at 13. 2,366 RPMs. Crazy spikes on the meter here. And we got our light. Sweet. It's only at 11.2 right now. 11.2, we got 500-volt spikes. That's amazing. That's just freaking awesome. All right, here. Let's turn it up to 13 where it was at. 600, we're cresting 600. I'm only looking at the one reading. That's the only one that I ever look at. 155 hertz. So that's a good number for me to plug into the signal generator when I'm firing off this one. Good place to start. But that Litz wire coil, man, is mean, mean, mean. Let's see. At 13.2, what are we looking at? Yeah, we're crusted at 2376. 2381. Oh, dang. Maybe I was wrong. 24. Are we going to make 24? Oh, man, we were so close. I'll just check again in a minute. So I guess the next step for me to do is to print the bobbins that will be, I think I'm going to make them round instead of triangular, like this, because they all get caught. The wires get caught on the triangle part. And before you realize that actually happened, because you get into a zone. Once you get into a rhythm and you have to count too, it's like nothing's going to get in your way. And you just 10, 20, 30, and you keep going. You see, I mean, this one I actually had a drill and I counted, but I mean, and they still got caught. Got caught easier with the drill. 600. Gonna give the circuit a little time to cool off. I'm pretty sure it's cool because there was no like hiccups in the system. Yeah, I don't feel any like extreme heat coming off the transistor. It's a little bit. I mean, yeah, everything's like room temperature or a little above. So again, here I was also planning or thinking about, you got two ways to do this. You can go here, and you can put the next coil here, like right in the pole, and then it would like, cascade that way. And I think that's the way we're going to start doing it. But then you can also put the coil over here, or where, the magnetic field extends to out this way, and, sync them that way. And I want to be able to do that. See that these coils are exactly the same. This one's a little bit more pregnant than this one is, but I can't really do anything about it now. They are both 1500 turns though. Yeah, man. It's amazing. I thought for a second, like, why haven't I been able to do this? And it's because this is a slightly different way of harvesting the energy. What I normally do and what I don't, I mean, an electromagnet is a magnet, so don't get me wrong. I know what's going on here. But usually I have this coil up against the wheel in an open spot, and it gets all of its energy from the perm magnets. This is electromagnet. Haven't done really any work with electromagnet on pickup coil. It's always been rotor to pickup coil. And I hope that if we can get it to go like this, like send a pulse through this one, and then it links through that one, and there's like zero loss, and you end up being able to hook up multiple. I don't even know, like hooking it up this way and having I'm going to say EMF pickup from the side and just have it link in that way. But we're going to start by building it like this. And I'm telling you right now, this is a third of it in the drive section. And then I didn't have enough to make a third one, so I built this Litz wire coil. Boom. So it's not 1500 turns. All right. Man, I'm just so excited. I think that it's going to sink down to everything being 1500 turns. I really do. And whether I do 36, 38, or 32 or 34, doesn't matter. Because at 1500 turns times 6 is 9,000 turns. All that should be able to see, this one generates about 10 volts. Well, actually, we should hook it up. I don't want to be like getting my feeling for this wrong. You know what I mean? I'm doing this all by touch. And there is some math involved, but I think I do the math with the touch. It's what it's all about, man. Feeling your way through it is all about the math. Because I'm not working with high voltage, I can do that. I've been shocked by this thing about 5 times in the 3 years that I've been working with it. And every time I'm not going to forget. It's like I picked up a bridge rectifier when the thing was on. I got a nice shock from that. Like, felt like I put my finger in a light socket. You gotta have reflexes to do that. Unintentionally, of course. How did you unintentionally put your finger in a light socket, dude? I don't know. Maybe I was curious and it was on purpose, but I was really young too. But I remember that feeling. It's not healthy. So this is 3,000 turns, and I'm going to give you the readings on it. I might bring the phone around. Yeah, man, no doubt. I didn't do it on purpose, like shock myself on purpose. I was just curious. Yeah, but if it gets to a certain part of your body, I guess like your brain or your heart, it could shut it off because it's all the same stuff really, and just it's like getting over like an OD of what's good for you. No, I don't know. I don't know. I know it's really dangerous, and I know that it hurts. I've had one thing catch on fire in 3 years. I think that's good. That's a good. And I put it out right away. What's the first thing I did? I cut the power. Huh. So it's generating 20 volts right now. The spikes are lackluster. About 140. This is 3,000. About 17 volts. And that's way more than what we need. It's just that, like this one, doesn't register many volts. And I think it's because there's more plastic than iron in this. And you got to do an air core. And I'm going to make the air cores big enough to put some real iron in. Because, I mean, it is what it is, man. I made it solid and even put this so I could run it on the drill. And it doesn't even pick up a whole volt. And I think it's right around 1,500 turns. That's not right. Something's not right. So I'm going to make them with the hole in the middle. And I'm going to make them so I can like do a 1/2 inch of soft iron. Yeah, so 17 volts out of 3,000 turns. And if we break that in half, with the air core, I think I don't know if it's going to be exactly half because the shape itself is going to be different. It's going to be longer. It's not going to be as far out. See, it's not wrapped around the hole. There's actually like, I don't know, 3/8 of an inch all the way around the hole of material, 100%, filled in. So there's a core there already, in my opinion. but putting a soft iron core in there is actually better. Can I moonwalk? No. Hell no, man. I used to be able to do stuff like that. That was, I'm over the hill pretty much. So I haven't done anything, dancing, and I don't know. I haven't been keeping track, but like Vanilla Ice. I'm just kidding. All right. Maybe I should write that down. Let me make sure. Okay. These mics like to die on me. Oh man, here it is. So not only are we going to write down the digits, we're going to make a 2 scale. Little drawing here of the bobbin that I need to run through Tinkercad. Now I think it's going to be like that. And I can make the shape like better in the Tinkercad. So basically like that. It's got to be that big minimum. We might be able to draw that in a little bit more. Instead of making it an eighth, make it like a 16th. Anybody got recommendations for diodes? Like what type of diode I should use in this setup? Just a regular rectifier. I mean, I got these are 1,000-volt 4 amps. Probably just use those. But I don't know if they're right for the capacitors, man. Is there a special? Low voltage. It's what am I going to do with it? Well, what I'm going to do with it is I'm going to take the energy from the 6 coils, and I'm going to run it in the direction of the next. I'm going to use it to point the energy to its destination. which is the next one of these coils. Don't even know what to call it, really. Drive coil. So it's pretty much going to go like that. This one pulses. This one picks it up and sends it to this one, which will pulse. Let me look real quick. I think are those they're the little ones, right? 4002. It's a propagator. The end goal is to have well, basically to see how long and how much voltage I can get trapped in a hexagonal shape. So it's going to be looped on itself. It's going to be in the end it's going to cascade on itself. I'm trying not to use capacitors because that's going to put it's going to put a cap on it. Really, that's what it's going to do. Chotsky. All right. Thanks, Nick. I'm that would be great. I want to break this propagator down into sections. So if we could like isolate it into a section, then it would be really easy to understand. So there's a pulse width modulator, right? I think that's what it's called. I got it right here. I'm glad I remembered where I put that. That's so cool. So I have a signal generator right here, and we hooked that up to it. But for final product, we want to use this in a section. Probably a 12-volt battery pack in at least one of the sections. But it's going to be like off to the side. Instead of using a starter cap, we're going to use a starter battery pack. Is that right? All right, good. All right, yep. Now there's a lot about it that I don't understand, but in theory, it should be, pretty simple on how it's going to go. And I'm thinking, honestly, we're going to avoid using capacitors unless the capacitors are going to be of a higher voltage. Because I do believe, and I don't think we should use them unless we can auto dump them before they're full. If we can do that, that would be great. Then we would use them. And then, if like we're throwing around 300 volts in this thing, we get 400 volt capacitors and we auto dump them. No worries. We're not even at potential yet, so we're good. Yes, Brian. Thank you for elaborating on that. Yeah, an electromagnetic propagator. Now, I don't know what the ultimate effects of that are going to be, but as far as I can tell, at the size that it is, it's going to be, if any like electronic equipment's going to go out, it's going to go out in my house. That's how big it is. So ultimately, it's probably going to end up being about 1.5 feet in diameter. And I'm pretty sure that the drive coils will be affecting drive coils and whatnot. And I think it'll be okay, honestly, because the more energy we can generate with the pickup coils, the better this thing is going to, go. This would be great if this works, because I've been trying to do something like this since I figured out like how a transistor worked, which wasn't 3 years ago. It was more like 2 years ago. Right, right. Very versatile. That's why I called it my versatile pulse motor, because I can actually hook up all this stuff to the rotor and do that, even though it's a single file coil, because I have this propagator coil, pickup coil, that I can turn into a trigger coil, and it'll run this one or that one or both of them with ease. I love it. I love it how versatile it all really is. And I feel that there's a lot of power involved in the planning, the method. Okay, the method is important. If you're looking to like replicate something or do something that's very specific, I mean, it is so important that you do it the right way, or you're not going to get the right answer. Oh, oh, oh. But as soon as I get the perfect size coil, and I think we have it now, it'll go real fast from that point. I mean, as soon as I get the 6 coils made for the first 2 to link up, and it works, that's the thing, man. It's got to work. So as soon as I get that made up, I'm gonna do another live, and we're gonna see. It's either gonna be like, okay, what do I do now, or it's gonna be like, oh yay, we got it, or it's gonna be like something like that, right? Now I can see, since it's an EM burst that's propagating, if this thing continues to, that's why I said I'm glad it's so small, because if any of the electronics are going to go out, it's going to be in my house. Yeah. Here, let me put the pickup coil behind the drive coil over here. Oh yeah. So 3,000 turns in this configuration, slightly off center, is making me 21 volts. I'm only putting in 14. 2,300. I just think it's awesome that you can pick up all that power contactlessly. I mean, even that backed out. It's like backed out now a half an inch. It's only 3,000 turns. Still generating 4 volts. And the power's off. So here, let me turn it back on. Yeah, we're generating 10 volts, like, and there's a half-inch gap we could utilize. But that's for, I'm just testing out the EM field. I really should be trying to test the EM field with a signal generator or a PMW or PWM, my fault. Yeah, I'm not making an EMP. It's not a weapon. Well, it is an EMP, but it's not an EMPW. Okay. As far as I can tell, at 2 coils, well, they haven't been linked in a loop yet. And I still have a hunch, and it's a small hunch, but I'm thinking that unless we figure out like 2 very specific things, this isn't gonna work. It'll all be on at the same time, and that's not what we want, really. We want not what I'm thinking in my head. I mean, what's gonna happen is the voltage is gonna continue to increase on the meter. I don't know actually what's gonna happen, but I'm pretty sure this is harmless. If I was really worried about it, I wouldn't have my table so close to my television. Cost quite a pretty penny, so I'm not interested in having it go away. But yeah, I mean, right now, what I could do for demonstration purposes. I'm going to set it up on the side of the table here. We use coils that I already have. They're going to be bigger. I need to move the camera. But let me get this stuff put down first. Um, oh, don't know what you mean by that, Chris. I'm not really trendy, if that's what you're talking about. First time hooking it up this way. And I'm just going to hook it up in a straight line. Yeah, I don't know. I think my signal generator is going to be a little shy. But it's only got to reach that far. Okay, I think we're good. Um, See, now I have a question, kind of how I'm going to hook up the second coil. Actually, I'm going to need a longer one. All right, let's see. Is this good? This is good. Here we go. What we need. Then one coil, the coil will go to this bridge rectifier. And from the bridge rectifier, it'll go to the next coil. See, now what the problem is that without the pulse to open the transistor on the next coil, I know the first coil, the first section is good. So does each section need its own pulse width modulator? We'll see. I'm hooking up the first pickup coil to the second coil. Yeah, I can't wait to get rid of this table. I can't express enough how much I've loved using it, but All right, now we're going to take this one. Oh man, I only have the one. All right, just for the sake of testing this out, I got to unhook this. It's all right. Oh, that's the broken one. Okay. Now these two sections should technically be able to cascade on each other. Am I right? I hope I'm right. All right. Now, since I'm using a full wave bridge rectifier, do I need to rectify any further? Because I'm hooking this directly back up to the front here where the power goes in. I would think no, because it is several rectifiers, but I don't know. Gonna hook it up though. Oh, I do. I do need a rectifier, but it needs to come from the other side. So the transistor, yeah, that'll work. Right. So this will go here. Now I'm going to plug a light into one of the coils, and I'm going to plug the meter into the other one. Yeah. Right. So the light go in the far one. So the blue one is the light. This one. Man, dude, I hate wires. They're like flexible when you don't need them to be, and then when you need them to be flexible, they're hard as a rock. Oh man. Okay, there we go. And now the meter. All right. Okay. Now we have to put, it didn't take too long. All right. Signal generator up. Now this would be a lot easier than I hooked it up the last time. See what happens. So it's at 12 volts. I don't think I can use the rectifier in the on. Can't use it where I'm putting it. So I don't know. See what happens. Oh, just one LED right now, and then the meter's hooked up to the other bridge rectifier. So we're going to get a reading, and that reading is going to be the evidence of the light. Oh, my fault, Signori. Signori, my fault. I still have the other coil hooked up. God, I hope I didn't break it. Let's see. 12 volts. There we go. Yeah. All right, we got a light at 1 hertz. And it looks like it's starting to propagate even here at 1 hertz, 2 hertz. It's at 8. Wow, dude. That's just a substantial increase in the hertz. I'm at 4 hertz, and it's at millivolts right now, but it's still substantial increase. All right, I'm going to skip to the 10s. Leave it at 4. All right. So it's at 14. Huh. All right. We are not cascading. We are stuck at 6 millivolts, 0.1, and we're at 164 hertz. That light is bright, and maybe it's the light. So this is 1 hertz at 12 volts, and we are not really generating anything that the meter can find. So what I'm going to do is I'm going to remove the meter and I'm going to put another LED in there just to see if it's working right. Because the meter's not really showing me much right now. Don't know. Maybe there's not much going on. So I'm thinking there's a step here where I'm connecting back to the original source coil. There's something that's not happening that I'm missing. Choose this one. All right, now they should both turn on. Yeah, they are both not turning on. And that's weird because well, it's not weird. It's just going through all the. The light's not turning on. I think that's weird. Maybe I need to increase the hertz for this one to turn on. Let me try that. Nope. I don't get it. It's all right. Here, let me see how much spikes we're getting. Now I've unplugged that light. Let's see if that light turns on now. Nope. So this looks to me like a very weak pulse at 12 volts coming through there. Don't even really know how to proceed with these single file coils. I don't even know. I'm not getting anything that would qualify as a usable reading right now. But I'm gonna plug this light into this bridge rectifier. It could be the bridge rectifier. I don't know. Something not right with that connection. But it's good enough for the energy to flow through it to the next one, you know? And it's not gonna turn on. I already have a pretty good feeling. Yeah, I don't know. My components, especially this big bridge rectifier, is definitely in question. At least one of these are. Maybe you're not supposed to use two directly in a row. I don't know. I don't know. Trying to make this the sections congruent. That mean a bridge rectifier per. No, I don't know. Maybe I can't do it that way, and I got to do it a different way. But you get the general idea here. So I'm thinking that if I did something weird, I forgot already what I was thinking. It was with the bridge rectifier and taking the output from this. But that's what I'm doing already. But if I take the ground and plug it in, I don't know. I was thinking maybe I split it and put the power in. This is power in, and then have the ground of this one be put somewhere else instead of the ground of that coil. Maybe that's where I need to put the diode. And yes, all these wires, extra wires, they do mess with your circuit. They change all the numbers. They're all different. But, it's as close as you can get without, a soldering gun. I think that's the best way to eliminate all the excess. um, yeah. Shoot. Mm. I'm plugging this one back in just to see if it's working now. The light's working for the second one. I mean, the power's going in the first one and out the second one. That's one given that it's working, but getting a reading off of this bridge rectifier seems to be impossible. I think this is where you would put a cap in. And maybe we will use caps instead of instead of hooking the bridge rectifier of the first one into the second one, hook it into a cap. Or maybe I actually need to have all the sections. So you gotta have the power. That's weird. Let me turn the power off, see what happens. Hey, high society. Well, my bad. Society of High Sciences. I always wanted to say it the other way, though. All right. So what's going on right now is the power is going in to this one. It's being picked up by this one, being dropped off to this one. The light is being pulsed by this one. And when I take it off the loop, so when I disconnect this one from the front here, the light turns off. So we got some energy flowing in a loop. That much I'm aware of. Whether it's what we want, I don't know. Yeah, this meter is not. It's at negative 3 volts. Oh, that's why. Haha. Oh, man. Come on. Now it's not going to clip. This one's too broken. Nope. Nope. Yeah. I'm going to try and find another one of these real quick. Just use this one. That's good. That's good. That's exactly what we need. But look at how huge these coils are. They're way too big. We want to get it out of 9,000 turns, broken into 6 pieces. All right, so now we have no LED on there right now. Oh man, that just doesn't seem right. Let's turn up the voltage a little bit. Oh, frequency first. Well, it's like 4 volts. That's not anything like what I was getting before. But that is going through 2 sections instead of 1. What was that? 155 maybe? The hertz that it was reading on the wheel over here. About 10 volts. It doesn't make sense to me. Heck yeah. Been getting it backwards since I started doing it. And I think I know why it is, or I think I know. I don't know. I have no idea. I do know that in a loop, this thing is together. I don't know if it's propagating. I should definitely try and find that out. And what I think we can do to get it to propagate like efficiently is to get oversized capacitors and then leave it on until they fill up. Uh, so this is the meter. Where do I want to put it? Because I know that there's more flowing through here than I can see on the meter. And one of these bridge rectifiers over here is only like a conduit. You can't get a reading off of it, and you can't hook anything up to it. But it is what is allowing the electricity to flow from this coil, from this coil to this coil. Oh. Man. Can't there we go. Some of these clips are like beyond repair. Look at that. I did it all with it on. I can't believe how dumb I am. Can't believe that, man. That's 150 hertz at 20 volts that I could have got shocked with just now. And I think it's funny. It's not funny. That was the dumbest thing I could do, really. All right. Yeah, so I don't know what's up with that first bridge rectifier, though. Maybe I need a transistor for each section as well. Does that make sense? Because I think I'm just plugging one into the next one, and it's not working the way I want it. So we get another transistor. And we plug the pickup coils into this. Oh, man. There's another one. Good. Just in case. What the pajangas? I don't even understand how. Well, I do kind of. You lose track of what's on top of what. There's only one rule. You got to do it my way. Mm. There. I probably need more slack than that. All right. This is a ground, so that's what I'm looking for right now is a ground. I believe this is it. All right, so now we're going to pulse through the Eve distribution. Put this one down here. Yeah, that's going to free up. come on, man. There we go. That one's hooked up. Now, this is to the signal generator. Voila, now they both can be pulsed. I think I might actually go with that, either with the PWM or the other way. All right. So that one, also this one, and this one. It's going into there. Is that right though? Yeah. This one's going into that one. All right. I think that'll work. I don't know. If there's any problems, it's got to be with that ground right there. Maybe I can hook it up to an emitter somewhere. Oh, right then. It's going to go through the coil first. I think that's right. Oh. Oh, not this time. Just looked at the other one. This is the way we're doing it. We might change that though. All right, so now we got a ground again. And it's all dependent on your perspective in most cases. And like how you would grab your components to apply them to what you're doing. If you grab them from this side, it's going to be really opposed to if you build it and you're grabbing from this side. It just is. It is an is thing. You know? Not like pointing any fingers or anything, because it's hard for each other. And yeah, I'm talking like kind of like maybe don't know if it's like lefty righty kind of thing, or if it's like something else. But I can tell when it's like either somebody's just thinking differently than I am. And definitely wouldn't know about any of that. That is a matter of opinion. All right. Ground. Looking for a ground. All right. We'll see if this will work. I don't know. Maybe it's going to work. Do I want to hook up a neon? I guess. Let's gather up all this stuff first. And then if there's a 32 gauge wire that's really long, just kind of floating in there, it's probably getting all caught up in that stuff. At least then I can just feel good about breaking it down to size, cutting it up. Hi. I'm sorry about that. That was a very important phone call. It's all right. It's good. It's good. It is good. So I am going setting this up. So we got the light bulb, power, power, coil, and this one. Now see, this is where I get confused. Now I got to hook this up to a bridge rectifier, and then from that to a transistor. Do I hook it up to the same transistor, or do I have a third transistor? I think that we could do a third one, and that would act as an alternate to power the first one. I don't know if that'll work. Actually, I want to just see, honestly, if this will work. I guess we could do a rectifier right into the collector of the first transistor. Huh. Since these are all grounds, we're gonna do it like this. I have no idea. I don't know if that'll work. So I feel like sometimes it works that way and sometimes it doesn't. And you need to put additional rectifiers in leading to that connection, which is now I have 3 grounds going into 1 diode, and then the ground connected to the, what is it, the cathode? Wow, this was complicated in the end here. Hopefully it'll all work the way I want it to. Sweet. All right, I'll be right back. To turn this on, just have to ground this bridge rectifier real quick. Well, let's just do it with this. Hey, Tiggs. Meow. All right. 12 volts. Here we go. The meter is not plugged in. And plug it in. See, now, if this is what it takes to do, I'm going to have to, it's going to take me a lot more time to do it. 12 volts. Nah, something isn't right. 12 volts should turn on the lights. I don't know. I will figure it out, though. Let's try this. Go. Hey, Tiggs. You gonna get zapped? All right. Hmm. I got an idea. Hold on a second, Tiggs. Gosh. Yep, that was gonna happen. Tiggs, wanna pick that up? I don't even know if I could do this now without picking all that up. I don't think I can. But what I was gonna do, I guess I can do it as long as this is off. Turn the voltage down. We're gonna do collector to collector, and that might be how we have to hook this whole thing up. It's not supposed to be like that, but there's just, it's not. I'm not hooking it up right. And I mean, why in the hell would I be freaking with a Tesla coil if I can't hook this up right? There's no point. That is the pointless thing right there. It's like, how can I do that? I mean, and then if you mess up, you kill yourself. I don't know. I blew a 100-volt capacitor, and I had to check to see if I was still alive. You know. No, unintentionally. Blown the thing unintentionally, so it caught me off guard. Yeah, I don't know. This isn't going to work. At least the meter's not working, and it's kind of discouraging. So I will mess around with this at a later date, and I will start making the coils for the collector. And it's not going to be these ones. Careful. All right. I'll check you all later. Thank you for hanging out. Peace out.